Biogas is an age-old fuel that is being produced in India through anaerobic digestion process using animal waste. With the advancement in technology, increased scale of production and diversification of available feedstocks, it has now been transformed into compressed biogas or CBG. This modern form of bioenergy can be used interchangeably with compressed natural gas or CNG. Hi, I'm Dr. Rahul Jain. I work as Deputy Program Manager in the Renewable Energy team at Center for Science and Environment. Today, I'll be talking about our findings on the compressed biogas. The major difference between biogas and compressed biogas is their composition and properties. Biogas is a mixture of gases like methane, carbon dioxide, nitrogen, and hydrogen sulfide. CBG is a purified form of biogas that has been compressed to high pressure, that is 250 bars, and has undergone further processing to remove impurities such as CO2, moisture, and hydrogen sulfide. This results in a gas that is primarily methane and can be used as a substitute of natural gas. CBG offers multiple advantages. It primarily reduces the need for CNG imports, which currently constitutes 46% of the total consumption. CBG sourced from available organic waste can address the gap without requiring new infrastructure, as it seamlessly integrates with existing natural gas structures. CBG promotes in-house clean energy production, enhances waste management, strengthens the rural economy, and expands the non-chemical fertilizer sector. This aligns with the Indian government's goal of transitioning to a gas-based economy, aiming to increase its gas share from the current 6.5% to 15% by 2030. So the major feedstocks for CBG generation in country include agricultural residue, animal waste, organic fraction of municipal solid waste, press mud, which is a waste generated in sugar mills, and sewage sludge. The following schematic illustrates the CBG production process using diverse raw materials. So the graph basically illustrates the quantity of different feedstocks that are required to produce 1 ton of biomethane or CBG, and its application in various uses such as automotive fuel, electricity, heat, industrial applications, and biohydrogen generation. The year 2018 marked a significant turning point for India's bioenergy sector with the introduction of two ambitious initiatives. Number one, the National Biofuel Policy, and second, the Satat scheme. Launched by the Ministry of Petroleum and Natural Gas, aimed to stimulate the production of 15 million metric tons of CBG from 5,000 plants by 2023-2024. In May 2022, the price of CBG was indexed to the retail selling price of CNG, with the lower limit fixed at Rs 46 per kg plus applicable taxes, and procurement price kept between Rs 54 and Rs 70 per kg. However, the sources of their production are completely different. While compressed natural gas is a type of fossil fuel, compressed biogas is produced from different waste generated out of our daily life cycle. Thus, CBG has the dual advantage of being cleaner fuel and reducing our waste problem, thereby contributing to the circular economy. The Ministry of New and Renewable Energy unveiled the National Bioenergy Program on 2nd November 2022. This program includes incentives to cover the capital cost of CBG plants under the Waste to Energy program. CSE's report titled Greening India's Energy Mix with Compressed Biogas, which was released in April 2023, revealed that UP Uttar Pradesh possesses the highest CBG generation potential among all Indian states. According to CSE's latest report titled Compressed Biogas Landscape in Uttar Pradesh, the state has the capability to install 1000 CBG projects by harnessing just 20% of its surplus organic feedstock. In October 2022, Uttar Pradesh introduced its bioenergy policy. The policy sets an ambitious target to produce 1000 tons per day of CBG by the year 26-27. According to CSE's report, the western region of Uttar Pradesh is rich in feedstocks. These regions include Lakhimpur Kheri, Bareilly, Bijnor, Saharanpur, Muzaffarnagar, Bulandshahr, Aligarh, Sitapur and Hardoi. The sector is facing several challenges. There is a lack of uptake of bioslurry from the CBG plants. Instead of being considered a potential revenue source, it is perceived as a disposal challenge. OGMCs acquire gas from the plants on a best endeavor basis. This exposes plant owners to the risk of being unable to sell their entire gas production. Some plants are operating below their capacity because they cannot fully offload their gas. The absence of CNG gas pipelines near plant locations is another challenge faced by these facilities. Operational challenges frequently confront functioning plants, resulting in issues like gas leakage, inefficiency, and operating below optimal capacity. This arises from a lack of skilled personnel and inadequate understanding of biogas production systems. Uncertainty surrounds the funding provided by financial institutions. Banks commonly require high collateral as a standard practice, and interest rates start at a minimum of 11.5%. Moreover, the lack of capacity in lending institutions to evaluate CBG proposals results in delayed decision making. Encourage farmer-producer organizations through awareness campaigns to assume the role of feedstock aggregators, replacing the third-party private entities. A strategic plan should be formulated to expand gas pipeline infrastructure near CBG plant locations. To stimulate demand in rural regions, introduce incentives for the conversion of tractors and two-wheelers to run on CNG. To amplify awareness among farmers about the positive effects of FOM, Krishi Vigyan Kendras can play a pivotal role in education and outreach efforts. A practical approach would be to initiate a government-backed guarantee program to mitigate collateral requirements, thereby encouraging financial institutions to extend loans more readily. The economic feasibility could improve if cow dung is available at no cost, such as in case of cow shelters. On the other hand, municipal solid waste presents the most favorable economic scenario, offering the highest profit margin if segregated at source. There is a need to train people to operate the CBG projects. The training centers should be set up with short-term CBG courses to prepare manpower with the necessary skill set. While 80% of CBG plants currently rely on press mud, there is a need to diversify the sources. In addition to solid organic waste, efforts should be directed towards utilizing liquid effluents such as spent wash from distilleries, industrial discharges from paper and pulp manufacturing, and other liquid industrial wastes. It is high time that these policy enablers are considered and acted upon so that strategies can be developed for immediate, mid-term and long-term action to enable India to achieve the green energy transition.